In this video, I will explain how to find the initial angle in a projectile motion problem in physics. So let's jump right into an example. This says, a soccer ball is kicked with an initial velocity of 15 meters per second, and it lands 20 meters away. Find the initial angle the ball was kicked at. So I've sketched out this situation where we have this person kicking this ball. The initial velocity, again, is 15 meters per second, and we know that the ball lands 20 meters away from where it was kicked. So our question is, based on this information, what must this angle have been that the ball was actually kicked at? So here's how we're going to solve this one. We're going to recognize that the ball is kicked from the ground and it lands on the ground. So it's starting and ending at the exact same vertical position. So when this is the case, we can use the following formula to find the range that the ball will cover. We can say r, the range, that's equal to the initial velocity squared times the sine of 2 times the angle, the initial angle that it was kicked at, divided by gravity. So what we'll notice about this equation right here is that we know the range already, that's 20 meters. We also know the initial velocity, and we know the magnitude of gravity, which is 9.8 meters per second squared. So we have all of these values, and we just want to find this angle right here. So we can go ahead and use all the values that we know to figure out what this angle is. So let's go ahead and do that. So we'll say r, the range, let's write that down here, 20 is equal to the initial velocity is 15. So we'll say 15 squared times sine of 2 times the angle divided by gravity, which again, the magnitude of gravity is 9.8. So we want to solve for this theta right here. So let's go ahead and multiply both sides by 9.8 to get rid of this 9.8 in the denominator. So we'll have 20 times 9.8 is equal to 15 squared is 225. So we'll say 225 times the sine of 2 times the angle. So to solve for the angle, let's go ahead and divide both sides by 225. So these 225s will cancel out. This left-hand side right here, if you punch this into a calculator, that comes out to about 0.871. And on the right-hand side, we have the sine of 2 times the angle. So we want to figure out what this angle is, so let's get rid of this sine. And we can do that by multiplying both sides by the arc sine, or the inverse sine. So we'll say the arc sine of 0.871 is equal to, on this right-hand side, when we multiply by the arc sine, we'll just be left with 2 times theta. So if you punch this into a calculator and make sure that your calculator is in degree mode, here's what that comes out to. 60.575 degrees. And on the right-hand side, we just have 2 times the angle. So to solve for the angle, we can divide both sides by 2. These 2's will cancel out, and we'll see that the angle is equal to 60.575 divided by 2. That's 30.29 degrees. So this is the initial angle that this ball must have been kicked at in order for it to land exactly 20 meters away from where it started. So again, to solve this type of problem, this is the key equation that we used. We just filled in all the values that we knew, and we were able to solve for this angle right here.